Hey everyone, and welcome back to the Deep Dive. Today, we're going to be looking at vector databases,
Oh, yeah.
which is something that's been really changing the way that we build applications, especially with AI.
Yeah, it's definitely something that I think all early stage developers should be aware of.
For sure. And I think you always hear this term semantic search thrown around,
Right.
and vector databases are really enabling that. So
Yeah,
maybe we just jump right in and kind of talk about like what is the problem that we're solving here?
sure.
Like what's wrong with traditional keyword search?
Yeah, so I mean, with keyword search, think about it this way. If you search for apple, are you looking for the fruit?
Right.
Or are you looking for Apple the company?
Right.
Or like how to change a car tire? Are you looking for instructions or trying to find out when you should change it?
Yeah, and especially with images, I feel like that's where keyword search really breaks down.
For
Like
sure.
if you try to search for a specific photo of like Taylor Swift using keywords, like good luck.
Yeah, it's impossible to capture all those nuances of an image.
Exactly.
They're just words.
Yeah, so this is where these vector databases come in.
Right.
And I guess like maybe explain like at a high level, what is a vector database?
Yeah, so instead of relying on those keywords, they represent the data as numerical vectors.
Yeah.
And those capture meaning and the relationships between data points.
Okay, so it's more about like matching on meaning than matching on like exact words.
That's right.
Okay.
Yeah, so you're searching based on like semantic similarity.
Okay, I'm kind of curious, like how do you actually capture meaning in a vector?
So it's kind of like, you've got an RGB color code. You have
Yeah.
3 numbers that represent a specific color, right?
Right.
Now imagine expanding that concept to like hundreds or thousands of dimensions.
Oh, wow.
That's what these vector embeddings do. They use a large number of dimensions to represent those complex concepts.
So instead of 3 numbers for red, green, and blue, you have like hundreds of numbers for like all the different aspects of a photo of Taylor Swift.
Exactly. And we use machine learning models called embedding models, and they analyze the data and learn to represent it as these multidimensional vectors.
Okay.
So just like similar colors have similar RGB codes.
Right.
Similar images of Taylor Swift would have vectors that are close together.
Okay, so a photo of her performing would be closer to another concert photo than, say, a photo of her at a movie premiere.
Exactly. And that's how semantic search works. You compare the vectors of your query with the vectors of the items in the database, and you find the most similar matches,
Okay.
even if they don't share any exact keywords.
So you're kind of like searching through this space with hundreds or thousands of dimensions.
Yeah, it's kind of a mind-bending concept.
Yeah, it's like, whoa, how does a computer even do that efficiently?
And that brings us to like what makes vector databases so powerful. They use these specialized algorithms for searching in those high-dimensional spaces.
Yep.
And there are techniques like approximate nearest neighbor search or ANN search, and that allows them to quickly find the most similar vectors without comparing your query to every single item in the database.
So it's kind of like finding a book in a library without having to go to every single shelf.
Exactly. And there's another one called Hierarchical Navigable Small World, or HNSW,
Okay.
which organizes the vectors into this hierarchical structure that makes navigation and searching even more efficient.
Wow, so we've got these vectors that are kind of like representing these different concepts.
Right.
But where do they actually come from? Like who or what creates those vectors?
That's where those embedding models come in. They're the engines that turn that raw data into those meaningful numerical vectors.
Oh,
And they're trained on these massive data sets using deep learning techniques, and they learn to identify patterns and relationships within the data.
so for images, it's like recognizing shapes and colors and how they relate to each other.
Exactly. And for text, it would be understanding the meaning and context of words and sentences.
Yeah, okay, so we've got like data.
Right.
Embedding models turn that data into vectors.
Yeah. Right.
And then we've got vector databases that store and search those vectors.
Exactly.
But like, what can we actually do with all of this? Like, what are some of the real world applications?
Yeah, that's where it gets really exciting. From things like semantic search, recommendation systems, to AI chatbots, and even things like resume screening, the possibilities are vast.
So for someone building an app, that means you could do things like search by image or recommend products based on past purchases.
Exactly. Those are just a couple examples.
Okay.
Vector databases are powering this new generation of applications that can understand and respond to user needs in a much more intelligent and nuanced way.
That's really cool. So before we dive into some of those use cases,
Right.
maybe just give our listeners a quick rundown of some of the popular vector database options out there.
Absolutely. There are a lot of options out there, both open source and commercial, like Milvus, Pinecone, and Quadrant.
Okay.
And a lot of them even offer free tiers and really great documentation, so it's really easy to get started.
Oh, that's awesome. So it sounds like there's a lot of resources available for developers who are interested in building these vector-powered applications.
Absolutely.
Cool. So maybe we can just take a step back for a second and kind of recap what we've learned so far.
Yeah, what stands out to you so far? Any aha moments?
Yeah, definitely, I think for me, this whole concept of representing information as vectors in a multidimensional space is really mind-blowing.
Yeah,
It's like such a different way of thinking about search,
it really is.
moving beyond just matching keywords to like actually understanding the meaning.
Absolutely. And I think the exciting part is we've just scratched the surface.
Yeah.
The applications for vector databases are expanding really rapidly, especially as AI becomes more and more a part of our lives.
Yeah, it feels like we're on the cusp of like a major shift in how we interact with information.
Yeah,
And it's really fascinating to see how vector databases are playing a key role in that transformation.
for sure.
Okay, so with that foundation in place, are you ready to dive into some of the specific use cases?
Yeah, let's do it.
And kind of explore the power of vector databases.
Let's see what they can really do.
Cool.
Awesome. Let's start with something that I think a lot of people are already familiar with. Recommendation systems.
Okay.
You know those, you might also like suggestions.
Right. Yeah, like on Netflix or Amazon.
Exactly. And those systems use vector embeddings to actually represent your past activity,
Okay.
like the movies you've watched, the products you've purchased, even articles you've read.
Okay.
And they compare those vectors to vectors representing other items and find the ones that are closest in meaning and recommend those to you.
So it's not just recommending things in the same category, like it's
Sure.
actually like semantically similar in some way.
Exactly. It's about finding things that are similar in a much deeper way.
That's really cool.
Yeah. And that same principle can be applied to a wide range of other applications like semantic search, question answering. Imagine a search engine that can really understand the intent behind your query and return the most relevant results, even if they don't contain the exact keywords you used.
Yeah, that would be a game changer.
Absolutely.
Especially when you're researching complex topics or trying to find very specific information.
Right.
And speaking of finding specific information, one of the examples we mentioned earlier was resume screening.
Oh, right.
So can you explain a little bit about how vector databases are being used for that?
Yeah. So instead of just relying on keyword matching, which can be very limiting, you can actually use vector databases to find the best candidates based on semantic similarity.
Okay.
So you can create vector embeddings for both the job descriptions and the resumes,
Okay.
and then search for resumes that are closest in meaning to the job requirements.
So even if a candidate doesn't use like the exact keywords listed in the description,
Right.
you can still kind of identify them as a potential match if their skills and experience align with the overall meaning of the requirements.
Exactly. It helps companies discover those qualified candidates that they might have otherwise missed,
Yeah,
leading to a more efficient and effective hiring process.
that's great. So it sounds like these vector databases are really revolutionizing how we find information and filter information.
Yeah, they're really powerful tools.
But what about AI chatbots?
Oh, yeah.
We talked about RAG a little bit earlier.
Right, retrieval, augmented generation.
Yeah, can you maybe tell us a little bit more about how vector databases play a role there?
Yeah, so traditional chatbots are really limited by their pre-programmed responses.
Right.
They can only answer questions or perform tasks that have been explicitly programmed into them.
Okay.
But with RAG, chatbots can actually access and process vast amounts of information in real time,
Oh, wow.
making them far more versatile and intelligent.
So instead of just like having these pre-written responses,
Right.
they can actually go out and like search through a knowledge base or a database
Exactly.
and synthesize information to provide a more accurate answer.
Precisely. And that's where vector databases really shine.
Right.
Because by storing and indexing information as vectors, they allow those chatbots to quickly and efficiently find the most relevant information to answer the user's query,
That makes sense.
even if it's phrased in a way that wasn't explicitly anticipated by the programmers.
So we've got vector databases powering these like personalized recommendations, these intelligent chatbots.
Right.
What are some other exciting applications that are kind of on the horizon?
One area that I'm really fascinated by is multimodal search.
Okay.
So traditionally, we've been limited to searching for information using a single modality, like text or images.
Right.
But with vector databases, we can actually break down those barriers and search across multiple modalities simultaneously.
Wait, so you're saying I could search using a combination of text and images and even audio?
Exactly.
Oh.
Imagine searching for recipes with blueberries and then being able to refine your search by adding a picture of a pie or even humming a tune.
That's amazing.
That reminds you of a specific blueberry dessert.
It's like searching with all your senses.
It is.
That's wild.
It opens up a whole new world of possibilities for finding information and making connections
Wow.
that we might have missed before.
That's really, really cool.
And as AI and machine learning continue to advance, we can expect even more innovative applications to emerge.
Yeah, it feels like vector databases are really enabling us to interact with information in a way that was previously unimaginable.
I agree.
The potential is really vast.
It is.
So let's be realistic for a second, though.
Okay.
Building applications with vector databases sounds pretty complex.
It can be.
So what are some of the technical challenges that developers need to be aware of?
Yeah, that's a good question. One of the biggest challenges is actually choosing the right embedding model for your specific data and task.
Okay.
Different models have different strengths and weaknesses, so it's really important to carefully evaluate your needs
Right.
and select a model that's well suited for the type of information you're working with.
It's like choosing the right tool for the job.
Exactly.
Okay.
And once you've chosen an embedding model, you need to make sure that your data is properly prepared and cleaned
Okay.
before you generate those vectors.
So it's like garbage in, garbage out.
Exactly.
Okay.
The quality of your vectors directly impacts the accuracy and effectiveness of your application.
Right.
So data preparation is a really crucial step.
Okay. So we've got data preparation,
Right.
embedding model selection.
Yeah.
What other technical considerations are there?
Another really important aspect is performance optimization.
Okay.
So even though vector databases are designed for efficient search, you still need to be mindful of things like query speed and resource usage.
Right. Especially if you're dealing with these massive data sets.
Absolutely.
Or these real-time applications where speed is really critical.
For sure.
Okay.
Luckily, there are many techniques and strategies for optimizing performance, like using appropriate indexing methods, tuning database parameters, and even considering hardware acceleration.
So it sounds like building these effective vector database applications requires kind of a combination of choosing the right tools,
Right.
preparing your data really well,
Absolutely.
and then understanding those nuances of performance optimization.
Yeah, it's definitely a multifaceted challenge.
So for any aspiring developers out there
Yeah.
who are maybe feeling a little bit intimidated by all these technical complexities,
I understand.
what advice would you give them? Where's a good place to start?
I think the best advice I can give is to just dive in and start experimenting.
Okay.
There are so many fantastic resources available online,
Right.
including tutorials, documentation, and open source tools, that you don't need to feel overwhelmed.
Yeah.
Just start with a simple project,
Right.
like building a basic semantic search engine or a recommendation system,
Okay.
and then you can gradually work your way up to those more complex applications.
That's great advice. And remember, the community is incredibly supportive.
It really is.
There are forums, online communities, even conferences
Yeah.
dedicated to vector databases and AI, so there's always help available if you get stuck.
Absolutely. Don't be afraid to ask questions, share your experiences, and learn from others.
This has been a really informative deep dive. We've covered a lot of ground,
We have.
from those fundamental concepts of vector databases to the real-world applications,
Right.
and even the technical considerations for building with them.
For sure.
So what are your final thoughts for our listeners?
I think the key takeaway here is that vector databases are really transforming the way we interact with information.
Yeah.
They're empowering us to build this new generation of intelligent applications that are more intuitive,
Right.
more personalized,
Yeah,
and more responsive to our needs.
absolutely.
And for developers, I think this represents an incredible opportunity to innovate,
Yeah,
to create groundbreaking solutions, and to shape the future of technology.
that's an inspiring message. So for all you early-stage developers out there, don't be afraid to embrace this new, exciting technology.
I agree.
Explore, experiment, and who knows? Maybe you'll be the one to build the next killer app powered by vector databases.
I have no doubt that there are amazing innovations just around the corner,
Yeah.
and I can't wait to see what the future holds for vector databases and the applications that they will power.
This has been an incredible journey through the world of vector databases.
It has been fun.
Thank you so much for sharing your expertise with us today.
Yeah, pleasure.
So we've talked about all these different use cases, but I really want to circle back to that multimodal search example
Oh, yeah.
because it sounds like something straight out of science fiction.
It is pretty futuristic.
Like imagine a world where you could take a picture of a dress you like, hum a few bars of a song,
Right.
and type in like find similar styles,
Exactly.
all in one search.
And because vector databases can handle those different data types so seamlessly,
Right.
that kind of multimodal search is becoming a reality.
That's amazing.
It's already being used in things like e-commerce, where you can search for products using images, text descriptions, and even audio reviews.
Wow, that would make online shopping so much easier.
Absolutely. It's about making the search experience much more intuitive.
For sure.
And I think we're just scratching the surface of what's possible with multimodal search.
Are there any other like really exciting applications that you're kind of like personally enthusiastic about?
One area that I find particularly interesting is personalized medicine.
Okay.
By representing patient data, medical images, even genetic information as vectors.
Okay.
We can use vector databases to identify patterns and make predictions
Wow.
that could lead to more targeted treatments.
So instead of like a one-size-fits-all approach to medicine,
Right.
we could see treatments that are tailored to an individual's like genetic makeup and medical history.
Exactly. It's about moving towards a more personalized approach to healthcare.
That's really cool.
And that's just one example.
Yeah.
Vector databases are also being used for things like early disease detection, drug discovery, and even just personalized health recommendations.
It seems like vector databases have this potential to touch almost every aspect of our world.
I agree. And what's most exciting is that we're still in the early stages of this technology.
Yeah, for sure.
I mean, as AI and machine learning continue to evolve, we can expect even more innovative and impactful applications.
It's really mind-blowing to think about.
It is.
So we've learned so much about these vector databases, how they work, why they're important, the problems they're solving.
Yeah, it's been quite a deep dive.
What are some final thoughts maybe for those early stage developers who are just kind of getting started with this technology?
My advice would be to just embrace curiosity and start exploring.
Okay.
There are so many great resources available, like online tutorials, documentation, open source tools, community forums.
Right.
Just dive in and experiment, and don't be afraid to ask questions.
I think that's great advice. And I think, you don't have to build the next groundbreaking application right away.
Exactly.
Just start small, build something fun, and learn as you go.
Absolutely.
Awesome. Well, thank you so much for joining us today and sharing your expertise.
It's been a pleasure.
It's been a really enlightening conversation.
I agree.
And to all our listeners, thanks for joining us for this deep dive into vector databases. Until next time, keep learning, keep coding, and keep pushing the boundaries of what's possible.